holidays, a balloon remained inflated in the summer house. The air temperature on a late autumn day is 7 degrees Celsius and the cylinder volume is 7 liters. After firing up the fireplace, the temperature increased to 23 degrees Celsius. Calculate the air work in the cylinder during expansion as long as the air pressure remains constant at 100 kilopascals. Calculate the change in cylinder volume. So the first step I took to answering this question was calculate the initial moles of gas present in the balloon using the gas law PV equals nRT. So the temperature is going to be 280.15 kelvins. We have the volume from the question, 7 liters. And I'm going to convert the volume to cubic meters, and you're going to see why in a second. So the volume is 0.07 cubic meters. And I'm also going to, I think it's also important that I convert the units of pressure from kilopascals to newtons per meter squared. Pressure is force, newtons, divided by area, divided by meters squared. And so the gas constant is 8.314 joules per mole per Kelvin. And so I solve for N. I'm going to get 3.005 moles of gas. Remember also that joules are energy, a unit of energy. So energy, it could also be expressed as force times distance. That's work. So I converted the units there just to, it's important to keep that relationship in mind because energy could be a change in temperature. It could also be dissipated. It could also be used to do work, which is push something at a force over a distance. So next step is to calculate the change in pressure inside the balloon. Let's pretend that we're just going to heat the balloon, but we're not going to let it expand yet. So we're adding energy to the balloon, but that balloon is not going to do work on the surroundings yet. So the new temperature is 296.15 Kelvin. The pressure is going to increase to 105,700 pascals. Which is 105.7 kilopascals. Just keep that in mind. Pascal versus kilopascal. Now let's let the balloon expand until the pressure inside equals the atmospheric pressure, 100 kilopascals. And we're going to calculate the final volume of the balloon. The temperature is going to remain constant at 296.15 Kelvin. So the gas law can just be simplified to P1 V1 equals P2 V2. Solving for V2, we get 7.399 liters. So the balloon does expand. So going back to the definition of work, that one form of work is pressure, is changing the volume of something against a constant pressure. So the work done would be, you might have seen this in textbook as P delta V, pressure times the change in volume. And so we get this, 3.99 times 10 to the 4th Pascal liters. The units look a little funny. I mean, it doesn't really look like it. I mean, it makes sense, pressure, volume, but let's prove it to ourselves that this is indeed a unit of energy. Let's convert it to joules. And this is why I thought it would be useful to express liters as cubic meters. So when we convert the units, let's convert it to joules. We're going to see it does make sense. All of the units in the denominator are going to cross out with something in the numerator, except for and you're going to be left with joules. So the work done is 399 joules, and that is the answer.